Welcome to another video by Meston Educational Services. In this particular video, we are going to learn how to write a possible program in Python to obtain all the prime numbers between 1 and any given number. The process we will be using will be the sieving method, whereby we will eliminate the factors of the first number in our list, which consists of all natural numbers between 1 and the given number. So here is the code. The first line of the code is an input, and the input is in the form of an integer, whereby we are asking what is the upper value for the list that we are creating. So let's say I want to go up to 100. So in that case, my upper value would be 100. That would be a user input. Then based on the upper value, I'm creating a list which is titled A. And the range for the list is it's going to start from 1 and it will go up to one number higher than the upper value, because the way indexing works in Python, it is always one lower than the top value. And then in the third line, you will see I have created an empty list which is called B. And I am going to create a while loop. Within the while loop, I'm going to run another loop with a if condition, and it's a for loop. So the while loop will run as long as the elements in list A are more than 0. The moment the list A becomes empty, the while loop will stop. Now what is happening in the for loop is the first element of list A, the first element in list A is dividing every element in list A. So it starts with the first element in list A, then it will go to the second, third, fourth, and so on until it gets to the end of the list. So in the for loop, what will happen is every element of list A will be divided by the very first element of list A, and it will actually run through each of those elements. Now, if the element is a factor, that means the remainder is 0, it will remove that element from list A. So I've got that remove command over there from list A. And once it has removed all the elements, it will take the very first element which we had stored, and it will move it to the empty list which was B. Now this number actually is going to be a prime number. Then I'll go back to the while loop again. It will pick up the next element, which would be 3, and then it will eliminate all the factors of 3 from list A, and then it will move 3 into list B. So the append command is moving the first number from the list A into list B, and it is removing all the factors. All the elements in list A are eliminated, then this loop will stop. So it starts with the first element and then it goes into the for loop, whereby what it is doing is it is dividing every single element of list A by the first element of the list A. And if it completely divides the element, that means the remainder is 0, it will remove that particular element from list A. That's the sieving part. And then it will move on to the next element. It will go through every single element of list A and it will remove all the factors of the very first number, which is 2 in our case. Then what it will do is it will move this number 2 into the empty list B. So that's the append part over there. So the first element of list A is appended to list B. So because we have moved 2, when the while loop runs again, the first element by default would now be 3. And the same process repeats. It's going to take the number 3 and divide every element of list A by 3. The remainder is 0. It will eliminate that element. And then it will go through the entire loop and repeat the process for the next number, which would be 5 in our case. And it continues until list A becomes empty. When list A becomes empty, that's when the loop will stop. And as a consequence of this, all the prime numbers from list A would now be transferred to list B. Now I am going to remove the very first number from the list B. That is because the first element is 1 and 1 is not a prime number. So that's the reason for putting that remove command over there. Then I've got the command print all the list of prime numbers. So here it says list of prime numbers, and you will see the command I've got with the \n. That means print that in the next line. And then the other line, I'm just saying print, and it is counting the number of prime numbers. The length is actually counting the number of prime numbers in B. So here it's going to count there are that many prime numbers between 1 and the given number, which was the upper value that the user had put initially. Now let's go and run this program. So it's asking me for the upper value. Let's go and put 250. So now it has generated all the prime numbers. So the first prime number is 2, 3, 5, 7, and so on. And the last of the prime numbers we got was 241. So the print command says there are 53 prime numbers between 1 and 250. So the first print command was generating the list of all the prime numbers from list B. And the second print command is it's doing a count of the prime numbers between 1 and 250. Now, in the second part of this video, we are going to do exactly the same thing, except that the difference is this time we're going to generate a list of prime numbers between a given range of two numbers. So my first number could be 20 and my second number could be 90. So it will generate a list of all the prime numbers between 20 and 90. So here is the code. So the only difference is now I'm inserting a lower value. That's my first integer input, and then I have a upper value, which is the upper number. I'm still going to do the same thing, create a list A with I'm not going to actually go from the lower value. I'm still going to generate my list from 1 up to the upper value plus 1. B is still my empty list. I'll repeat the same process. The only difference is I will start appending numbers to list B only when the x value in the for loop, where I'm saying B is x for x in B, when x value is equal to or greater than the lower value. That's when it will start moving the prime numbers from list A to list B. Rest of it is exactly the same as we saw previously. So let's run this program now. So lower value, let's go and put 20. The upper value, let's go and put as 90. So now it's generated all the prime numbers from 20 to 90. So the first number is 23 and the last is 89. And it's done a count that there are 16 prime numbers between 20 and 90. So it's exactly the same thing that we did in the first one, except that we started moving the elements into list B only when the first element value in list A was equal to or greater than the lower value that the user had put.